So today we're going to be solving exponential equations. Now, this exponential equation, it says 3 raised to the x power equals 27. Now, we can know, just by looking at it, we know that, okay, 3 raised to the 1 power is 3, so I know 3 to the 1 power gives me 3. I know 3 squared gives me 9. I know that 3 to the third gives me 27. So I could just try numbers and plug them in to see if I could get the right answer, but we're going to figure out a way to do it today that's maybe a little bit more mathematical, and we know then that instead of just plugging in numbers, we're going to be able to find it every time. So the one thing I know is I know that 27, what I want to do is I want to make them have the same base. So here I have 3 to the x. I want to write 27 as 3 raised to some power. And so I know that that's going to be 3 raised to the third power. Now since I have the same base right here, since my 3's are the same numbers, what I can do then is I can take my two exponents, I can take my x, and I can take my 3, and I know that they have to equal to each other because 3 raised to some power equals 3 raised to the third power. So then I know that x equals 3. Okay, so that's a simple example of how to solve an exponential equation. You make them have the same base. So here they both had a base of 3, and once they have the same base, you can set the exponents equal to each other. So there's a couple of steps that we can do. Like we just said, the first is to get the same base. So in our example, we wanted to have them both be 3 raised to some power equals 3 raised to another power. And once they have the same power, then we can set the exponents equal to each other. So if I had 5 to the x plus 2 equals 5 to the 3x minus 5, I know then that I can take these two exponents, because those two exponents have to equal each other since the two sides equal each other. So then I would know that x plus 2 would equal 3x minus 5. Okay, and again, that was just an example, just like up here. That if I have the same base, the 5's, then I know my exponents have to equal each other. So I can set up an equation to where they both equal each other. So let's look at a couple more examples of this. So in this case, I have 2 raised to the 2x plus 1 power equals 16 to the 2x. So remember, our first step is to make sure that they have the same base. So I know that over here I have 2 to the 2x plus 1. I want to write 16. 16 is 2 raised to what power? That's what I have to think about. What power does 16, or do I have to raise 2 to get 16? So I know that 2 raised to the 4th power gives me 16. So 2 raised to the 4th is the same as 16, and then I can raise that to the 2x power. So you see what I did? I replaced that 16, this 16 right here, I replaced with my 2 to the 4th, because I know that 2 to the 4th power equals 16. And since I know that, I can just basically replace that, because it's the same exact thing. Now, I have 2 raised to the 4th raised to the 2x power. And remember that whenever we have a power raised to a power, we multiply. So I know that 2 to the 2x plus 1 equals 2 to the 8x power. Now looking here, I now have my same base. They both have a base of 2. And since they both have a base of 2, I can then take my exponents and set my exponents equal to each other. So I know that 2x plus 1 equals 8x. And then I can just solve this equation like we normally do with any normal linear equation. So I can subtract 2x from both sides, get that 1 equals 6x, divide both sides by 6, and then figure out that x equals, so my 6 will cancel out, and then x will equal 1/6. So I know the answer to my equation here is that x will equal 1/6. And again, just kind of reviewing, I took my bases, found a common base of 2. Once I had that common base, I took my exponents and set them equal to each other. Let's look at one more example. Now in all the other examples, we had two bases where we had one that was already in its simplest form, and we had another one that we had to get to look like it. So now I have this example where I have a 25 and a 125. Now 125 isn't 25 raised to some power. So what we're going to have to do is we have to think about what base do we think we can convert both of these numbers to. Now looking at this, I know that 25, now I'm thinking, okay, what perfect square is 25? I know that 25 is 5 squared. So I'm going to just start with my smaller number. So I know 25 is 5 squared to the 3x minus 10. And I want to know, can I think about 125 as being 5 raised to some number. And I can, right? Because 125 is 5 raised to the third power. So I've taken this 25, written it as 5 squared, this 125 written as 5 cubed. Now I have to deal with my exponents, so I know I have 2 raised to 3x minus 10, and so I'm going to have to multiply that. So I'll get 5 to the 6x minus 20, because I have to distribute that 2. On the right side, I'll have to multiply my exponents, so I get 5 to the negative 9x. Okay? So now I have my common base. They both are a 5. So now I can just set my exponents equal to each other. So I get 6x minus 20 equals negative 9x. I'll subtract 6x from both sides. Get negative 20 equals negative 15x. Divide both sides by negative 15. And then get that x equals positive 20 over 15, because those two negatives, negative divided by negative gives me a positive. Now I could simplify that a little more and just say that divide them both the top and the bottom by 5 and simplify it to be 4/3, and that could be my most simplified answer. Now again, we had to find a common base for 25 and 125, which ended up being 5, and in doing that, we were able to then then multiply our exponents. Once we had the common base, set our exponents equal to each other, and then we just solved our equation like we know how to do and got that x equals 4/3.